Hello everybody, pleased to be here, and this is my first FOSS4G, so I'm quite nervous. And this setting also looks like a schoolroom, so it also reminds me of how it was in school. And this is the education track, so good teachers, what did they do when the students were nervous? They asked them to go on a mind journey. So I asked you to come on a mind journey with me, and to close your eyes, breathe a bit and relax, and I will bring you to another world. So imagine a world where the number of satellites that is surrounding our planets is increasing yearly, maybe even daily. And in this world, we are adding on a daily basis images that are taking pictures of our world, and they're stacking up to terabytes, to petabytes, and I don't know the name of the next number of bytes what comes after this. And now I would ask you to come back to this world, and yeah, it's a similar setup I guess, but I have one question for you. And do you know any EO cloud processing platforms that can take care of all this data that we are piling up? Anybody? Maybe raise your hands if you do. Okay, so no. Exactly. Okay, perfect. And then I think the next question answers itself more or less. Do you know how to use them confidently? So I guess if you don't know them, then the chance that you know how to use them confidently is also quite low. And this is actually perfect, because this is what the talk is going to be about, and this is what this course that we are presenting today is about. It's called Cubes and Clouds. And before I continue talking too much, I will just show you the introductory trailer that we have made. And that should speak for itself. The audio is not working.
Your sound is off.
Yeah. Down here. Okay, but there's no... Okay, I can just comment for you while we're watching this. So you've seen some people that are in the mountains trying to measure snow. And it's not only one position that you want to measure snow on. So what is the solution? Luckily satellites were invented. First there were not many. Slowly we're getting more of these satellites. And they are recording data. And as I've said before, in the world we had imagined, which is actually our world, they're piling up to large numbers of data volumes. And the end of the story is that your computer is probably not capable of handling these amounts of data. So there needs to be a solution. The solutions exist, and that is cloud computing. So all the processing that used to happen on your PC can be sent into the cloud. Here you see an example of a normal workflow that you might be doing at home, calculating the NDVI or the NDSI using different satellite sources and the code. And this code is sent into the cloud, where there's a lot of computing power, some servers. And NDSI in this case is calculated online, and the different tiles, this is the concept of scaling, so that is quicker, so different tiles are calculated in parallel, and you get the result way quicker than before. And not only that you get the result maybe for the whole world that you're not interested in, you can zoom to the region that is relevant for you and extract only this information in all dimensions, since we're using a data cube. So that was an example of a time series. Once you're done with that, your result ideally is already stored in the cloud. You don't have to download it, and you can give access to a large number of people if you adhere to the open science principles. And ideally, this will help the research question that you had in the beginning. So this was the outline of the course in a nutshell. And I think it's time to start with the presentation now. So as said, this is the course Cubes in Clouds, an online course to educate the next generation of EO researchers or data scientists in data cubes, cloud platforms, and open science. The motivation that we have behind this is we should slowly also teach the new researchers how to do the transition from traditional methods of working. Let's say you're on your laptop, you're using QGIS, you're using Envy software, whatever, to the standards that are emerging. There are so many talks on the Phosphor-G about cloud native formats, web mapping, open science, fair data. So the concepts exist, but there are not so many training courses available, or they're mostly scattered around. So we're trying with this course to aid this transition and give a resource that is available to everybody and reusable for as many students as you want. So the main pillars of this course are one, the discovery of data. Since the flood of data that is available, it is already difficult to find what is available and how to find this. The second part is how is this data organized? There's also emerging standards for that, which are usually data cubes. So how do you handle this multidimensional data in the cloud? The second pillar of the course is the processing part. So how do you design the workflows that you usually did locally and port them to the cloud? And the third part is how do you share all of these results with a number of researchers that are maybe working on the same topic or that can reuse your data which you have produced. These are the main pillars. So how do we get there? We've seen the trailer before. The story is clear, I think. You can all imagine that story. And how do we package this into a course? So we start with the concepts. That is a very theoretical part to get everybody on the same page. So what is a cloud platform? What is an API? How does this work together? What is a data cube? So what is the multidimensionality of data? How do you deal with it? And what is open science? So how do you make your data really shareable and reusable? The second part is the discovery part. So there you learn to discover not only data, but also the processing that is available. So there we're mixing theory and application. So you start with data discovery. That is the catalog part, searching stuff. The second part is the data properties. So what are the values that are actually stored in the data on top of the metadata? Then the data formats and performance. That goes in the direction of cloud native data formats. And also the concept of scaling. So why is a cloud calculating the results faster than my PC? And finally, it's the data access and the processes. So you will start to really load data into the cloud platform and start playing with it, slicing and dicing the data, or just aggregating one dimension, for example, the spatial dimension, so that you get polygon results. And then the final step is the processing and sharing step. That is mostly application. There you will carry out a whole workflow. So from the start to the end, in this example, it will be generating snow maps. You will learn how to validate this data, and the final thing is you will learn how to share this data. How do you really adhere to open science? So how do you fill a STAC catalog, and how do you place your data somewhere where somebody else can find it? How do we convey this information? On the one hand side, we have the lectures. So they are structured, or the components that we use are scripts. So that is the backbone, like a reading book, and that carries the main information. Then we have videos that are a spotlight on a specific topic, and we try to work together with the domain experts here to get really their view and their newest ideas on the topic. They're short, like 2 or 3 minutes, and are really pinpointing one special topic, like, for example, the role of GDAL in cloud environments. Then we also have animated content. For example, if you look at a data cube, you can twist it and turn it and have the multiple dimensions. So just to make it a little bit more tangible and interactive. And finally, we have quizzes to test how well the students understood what we did. Here are some examples. So this is not yet the final way of how it looks, but you can see just the scripts. The videos are going to be a professional speaker with the concepts that we just said. And finally, the quizzes. The second pillar are the hands-on exercises. So there we are going to apply the knowledge that we've gained theoretically in real life, and we learn how to interact with data cubes, clouds, and open science, and that we're doing that through Jupyter Notebooks. The infrastructure that we're using, therefore, because it's not easily given that you have these infrastructures everywhere available. So the first thing you do there, you log into EO College that is hosting the course. And while you're doing that, you're already logged in also to EOX Hub. They are hosting the Jupyter notebooks, therefore. At the same moment, you get a subscription for Sentinel Hub so that you can use cloud processing. And you're doing the actual coding using openEO, which is a standardized language for cloud processing. And the highlight of this whole exercise is then the last step where every student carries out one workflow completely by himself. So our idea is that there's a map available that is persistently available, and the results that every student produces are displayed on this map with the metadata. So if he clicks on a tile, I will just show you. You find the information, you have the creator, you have the ID, you have the date. And so it's also a kind of community building effort that they really see that this is open science and how do you work together. You pick a spot that maybe has not been calculated before and contribute like this. And you learn how to really do it. And when you're done, you can also show that to your potential employer. Look, I've really done this. So it's also kind of a proof of concept that you know what you're doing. The resources that we're using, we've already talked about that. So we're starting with a GitHub repository. All the material that we're creating is openly available there. So all the lectures, you can go along there. You can trace also our status, because this is a work in progress, and we're happy for every collaborator that we find, for every contribution. Then, once the content is ready there, we're going to port it into EO College. That is a dedicated platform for EO teaching. So there are a lot of courses available there already that cover, for example, SAR data, that cover a zero hunger course that is they're available. So they have a lot of applications on other satellite topics, not only cloud processing. So we can backlink and forlink, and everything is in one place. And then finally, the exercises, as said, they are hosted by EOX. And that's going to be a Jupyter environment. You get the access to Sentinel Hub, and the final results will be hosted there and will be available through a web viewer. So, yeah, here again the examples that you see that this stuff is also really existing and you can find it. And finally is the call for collaboration. So how do we integrate all this into a broader ecosystem of EO courses? The first part is, as soon as we're ready, we will need some beta testers that test the course, which will probably be quite rudimentary in the first stage, and they will really get the criticism to fix the things that don't work. In a second phase, then we need some advanced testers, and yeah, that will be like the first cohort that goes through the course and leaves us feedback. So if you have, if somebody of you is a professor or anything or is interested in the topic, please reach out. We're happy to have the opportunity to share this course with you. The second part is the collaboration with the experts. That is possible through the GitHub repository, as we said. Or we are going to reach out to some experts. We don't know everybody in the field, so if you also feel that you have something to contribute to the course, please reach out. And finally, how do we integrate this into a broader ecosystem of courses? On the one hand, it's in EO College, that is itself already an instance, and on the second hand, we're trying to get this into some bodies of knowledge that are being put into place, so that the data is not only, or the course is not only standing by itself, but it's also referenceable through other sources. If you have any connection ideas, so please let us know, then we can talk about integrating it. It should be fairly easy from our side. And with that, I'm already done with the presentation. You have the different links for contact below, and we're happy to answer your questions and get in touch.